everybody, to this Nobel Prize panel discussion. To those of you who may not know me, I'm Professor Peter Calcagno, Professor of Economics here at the College of Charleston and the Director for the Center for Public Choice and Market Process. The mission for the Center for Public Choice and Market Process is to advance the economic, political, and moral foundations of a free society. Today, I'm very excited. We're going to have a panel to talk about the Nobel Prize winners from 2021. This panel is inspired by a friend of mine, a colleague at another institution, who does something similar and has always encouraged me to reach out across campus, always to bring in and to provide these types of environments where we can do cross-disciplinary and talk across things. And so my friend is the inspiration for this. So today we're joined by 6 faculty from the College of Charleston, all across campus, to talk about the 6 different Nobel Prizes. Right? And like the Nobel Prizes themselves, right, what we're doing here is getting to integrate both the liberal arts and the sciences. So today, right, our panelists are Gabriel Williams, who is Associate Professor of Physics, Michael Giuliano, Assistant Professor of Chemistry, skipping over Garrett, I don't know why, sorry. We have Garrett Milliken, Associate Professor of Psychology, Simon Lewis, Professor of English, Max Kovalov, who is an Instructor of International Studies, and our economist, our other economist, will be joining us towards the end, since he's going last. He's in another meeting, but he will be here. Christopher Mothorpe, Associate Professor of Economics. So with that, I'd like to turn it over to our panelists. They'll each take a few minutes between, say, 5 to 10 max, and I'll be keeping time, so you may want to.
Yeah, got it.
You need to talk about each of the various winners.
All right. Okay. So how are you all doing? As was mentioned, my name is Gabriel Williams. I'm in the Department of Physics. My background is that I am a physicist that works on atmospheric science. And so that means I have a great privilege to talk about something that is unprecedented when it comes to the Nobel Committee. And for the first time in the entire history of the Nobel Prize, we actually have atmospheric scientists that won awards in physics, which is remarkable because our field is less than 100 years old. So that means the work that these individuals have done would be considered groundbreaking, both in terms of the physics needed to understand the process and also in terms of the applications. So I'm going to walk in terms of the actual slides you see here, going from my left to your right, to my left to my right. And we're going to first start with the Japanese scientist, Sukuro Manabe. And so in terms of the broad reason why he won this award, he is the first scientist to actually design a computer simulation of global climate. And he did this in the 1960s. So for students who don't know kind of the computing revolution, in terms of what that would mean, he essentially ran a global climate model using a computer that took up the size of this room. And the actual memory on that computer is less than what you currently have on your cell phone. That is what he used to make the first official global climate model. And why he is important in terms of the history of the profession is that he is also the first scientist that linked together 2 physical ideas that we know by observation and by experiment. First, he was able to quantify what the greenhouse effect does in terms of global temperature changes. And second, he was able to predict the amount of warming that is expected from greenhouse gas emissions. So if you think about the actual whole course of global climate science in a nutshell, if you've noticed, most of it is based upon tracking the evolution of carbon dioxide and all of the other greenhouse gas emissions. The reason that that discussion has become such a big issue of climate science is because Manabe was the first one to show that there is a definitive link between those two. And so what his climate model did was to, in one sense, give you a quantitative reliable prediction of what that is. And secondly, he basically set the tone for the next 50 plus years of climate science modeling, because he was able to show that the warming of the entire globe is not solely due to natural processes. It is due to also all of the other emission processes that happen when it comes to gas, greenhouse gases, and other sort of atmospheric gas phenomena. The person next to him, who is Klaus Hasselmann, he is one who basically took that idea and kind of extended it. So when Manabe did his first model, that was in 1969, it was a pure atmospheric model. It did not include the oceans and didn't include any of those other phenomena. So what Klaus Hasselmann did was that he studied, in effect, how does the ocean itself, in one sense, retain the carbon that comes from the atmosphere, and how does the actual carbon itself help to feed through the entire atmospheric system. So he was kind of the first to combine ocean and atmospheric processes and pull them together into a coherent system. So what that means is that for Hasselmann, what he's able to do is to actually advance the entire global climate models that we see today. The last thing I'll say about what Hasselmann also did, and this is something you've probably heard from other people. People will often say, how is it possible for you to predict climate if you can't predict weather a week in advance? That's an old question that he answered in the 70s. The fact that it keeps getting repeated meant that people have never listened to what he said. Part of his research is essentially showing you how to detach the weather and rapidly fluctuating parts of the Earth system from the long range part of the Earth system. So once he was able to separate that, he is also able to determine how much of what we see in climate is human caused versus how much is natural caused. And that's why his significance is kind of there. Last person that you see here, Giorgio Parisi. He is a more broad scale physicist, but he's still within the entire scope of what we would call geophysics. What he is known for is studying what we call disordered or complex systems. So a great example of a disordered complex system would be the climate. But in terms of his own research, he was looking at how do you look at systems that look completely chaotic. So think, for instance, the motion of a flock of birds. Think of the stock market. Think of biological systems. All of the things that tend to be random and have multiple external processes pulling and tugging on them. So his work was to determine how you can actually predict reliable statistical predictions on seemingly complex systems. And he developed a method in which you can actually determine in very clear senses how distinct patterns develop in otherwise randomly oriented systems. So it turns out that his particular mathematical and statistical work was used in climate models. So one of the reasons that we're able to give you probability and statistical outcomes for future climate is because we're using the methods that Parisi developed back in the 1980s. So put that together, what these three men are doing in a big picture sense would be studying the effects of complex systems, how they interact, and how you can predict it. Manabe is the first to put that in terms of a climate model. Hasselmann is the first to put this in the sense of separating human and natural causes. And Parisi kind of gives you a mathematical and physical framework to piece that together. So, thank you.
So my name is Mike Giuliano. I'm an assistant professor of chemistry at the College of Charleston. And my background in chemistry dates back to sort of beginning with organic chemistry, so the chemistry of carbon-containing molecules, and has since translated to what we call bioorganic chemistry. So how do carbon-containing molecules, and how does understanding how to make them and what their structure is, how do those interact with living things? How is that at the root of how living things are there? And so when I was a young graduate student, much of the work that won this Nobel Prize was only 5 years old. And that's what, to me, is so crazy about this, is just how fast this revolutionized things. And so what I'd like to start with is a question for the room. How many of you have taken chemistry since high school? All right, we've got one of you. Okay, so that's why my approach today is going to be to give you just a little bit of background and historically why this kind of matters. And second, to tell you very briefly what the big impact was and show you at the end a couple quick molecules. And I can do that pretty quickly. If you haven't noticed, I'll move quickly and talk with my hands. So first, our Nobel Prize winners were Professor Benjamin List and David Macmillan. And both won for effectively what amounted to a very similar development. To reduce it down minimally, they controlled how bonds are formed in 3 dimensions. Right, how we can make bonds between atoms in 3 dimensions. And they did so with catalysts derived from organic material as opposed to, say, using metals, which can be highly toxic. And they both published the critical papers that led to this discovery about 1,000 pages apart in the same journal, in the same volume of the same journal in the year 2000. And 22 years later, we were looking at a Nobel Prize. And so why this kind of matters is that chemistry and molecules, the same things that compose all of us, exist in 3 dimensions. So if you were to look back into the mid-1800s, Louis Pasteur, and we still have them, was studying tartrate crystals. And what he noticed was that he could pick little individual crystals out, and that in them, he would find that some were mirror images of each other. And we know now that they are composed of molecules that are mirror images of each other. But at the time, it wasn't until almost 30 years later that the scientist Van Hoff, who if you've taken general chemistry, you'll learn about him, and maybe you learned about him in high school, but he said, well, that's because carbon looks like this. This is what we call a tetrahedral molecule, where we have 4 bonds coming out at equal spacing around a central atom. And what it gives is molecules a really unique perspective. If you were to take both of your hands and look at them, they look the same, and yet you cannot superimpose them. We call this chirality, coming from the Greek word for hand. And we noted that perhaps these mirror-imaged macroscopic properties led to, or were due to carbon having this unique 3-dimensional arrangement around it. So little molecules, like a molecule here of ethane gas, or molecules here like tartrates, which you find in wine sediments, have this property, but so do large molecules, and so do the medicines that we take that interact with large molecules. So on the left here is a protein structure. This is an opioid receptor. It's the structure of one that we find in the human brain. And when it binds small molecules, like this small polypeptide, a chain of amino acids here, you can see that I've shaded all of the atoms, all of the carbon atoms, that have a unique handedness, meaning a unique projection in 3 dimensions of atoms. So to activate that molecule, to bind it, and effectively send chemical signals relayed through your cell to cause larger changes like mood alteration, that molecule has to specifically project atoms inside a protein binding pocket. This matters for human medicine, and we didn't understand that until tragically it was too late. In the mid-20th century, the drug thalidomide began to be prescribed throughout Europe as a morning sickness drug. And what happened was its handedness changed in patients. And it went from an effective morning sickness drug to instead something that caused tragic limb defects and often miscarriages in well over 10,000 cases. And what this told us was that we had to synthetically control the handedness of the molecules that we make, most especially those for medicine. And so people tried to develop what we call catalytic methods to do this, where bonds might otherwise be hard to make, but we can reduce how much energy is required to make those bonds with the catalyst, right? And this became an exceptionally important thing, and actually matters economically. I know there's a lot of economists in our audience. It's believed that chemically catalyzed processes affect up to 35% of global GDP. Every chemical commodity that makes every feedstock, the polymers used to make your desks, that make the materials that compose your computers, every one of them is impacted by the concept of chemical catalysis. So why then, right? So it really matters being able to make bonds catalytically and being able to make them in 3 dimensions. So what did our Nobel Prize winners do? Well, they both built a similar structure where they had a molecule that was defined by a flat 5-membered ring. It was kind of like a pentagon if you looked at it from top down. And you'll notice in Professor List's chemistry, what he found was that, well, if we use the amino acid proline, right, we can buy this, it's cheap. You can buy kilograms of it for cents, okay? It would react with some molecule and attach a small piece to itself, and then use the other atoms on that 5-membered ring to bring in these two pieces so that the only way they could react was from a specific orientation. What does that mean? Well, it's effectively relaying handedness in the catalyst, to handedness in a product molecule. Professor Macmillan did something similarly using a reaction that did not set one carbon that had a specific handedness, but instead 3, 1, 2, and 3, using the same idea, where the structure of a small catalyst was so biased that the chemical reaction bonds could be made only from one orientation. So then why does this matter? What was the impact of this? Well, if you think about chemical research, we need to make bonds, we need to make medicines, right? To give you an example, that receptor I showed you, that class of receptor is responsible for anywhere between 35 and 50% of the targets of all FDA-approved drugs. We call them G-protein coupled receptors. And in the year 2000, you see a very small number here. And if you sum the first 8 years or so of organocatalysis research using small, naturally derived carbon-containing catalysts, we had about 1,500 publications. And in the last decade, we have had that many every single year. Right? So it has exploded and redefined chemistry. And what was it used to do? To take a molecule like Tamiflu, which was using massive amounts of natural resources, and to be able to reduce 12 chemical reaction steps to make it down to 5, and to set, with organic catalysts, all of the necessary handed carbons. And at the same time, we've also been able to get better access to these two drugs here, baclofen and roloprem, which are known to bind what we call the GABA receptor. These are mood-alterating drugs. Have you ever heard of the drug Lyrica? These have a very, very similar mechanism of action. And so Professors List and Macmillan both combined this knowledge of how to use catalysts to control not just how to make a bond faster, but how to control the direction of that process. And it has revolutionized how we think about bond-making processes in chemistry in less than 2 decades. Thank you very much.
That was really impressive. You were talking about keys to the systems. What I'm going to talk about is more the locks on the other side. We're going to be talking about receptors while you were talking about some of the chemicals that affect those things. So I think this goes together pretty well. If I could find these guys. All right, here we go. My name is Garrett Milliken. I'm in the Department of Psychology. I'm an associate professor. I'm here today to talk to you about David Julius and Artem Petapushin. That's a tough one to say, but I think I said it correctly. I looked online to find the correct pronunciation. That's the best I could come up with. These guys got the Nobel Prize for discoveries of receptors for temperature and touch. Temperature and touch. This is the more biological side of psychology, and neither of them are psychologists. They're both molecular biologists, and they do things to manipulate a lot of the genetics and things that go into basic receptors. Their work really did focus on how our bodies sense heat, cold, and chemical irritants. And we found out about the receptors for some pretty mysterious things. Now, I've got to give you a little bit of a lesson on physiology, because I know you guys have all had neuroscience, right? Of course. Everybody's had neuroscience, everybody knows about sensory psychophysics and all that, right? Well, I won't bore you with that, but I'm going to tell you about this, all right? This is your garden variety nerve cell right here. This is also known as a neuron, right? This is actually a motor neuron, and you can tell because it's making a connection here with the muscle. Now, what these cells do is they basically generate small electric currents. And they do so by virtue of the fact that they have these strange structures in their skin. This is kind of like if you blew up the skin and took a section off of the neuron, this is what it would look like. And you can see that these proteins here in green, they're not really green. It's a cartoon, all right? But these things actually span the skin of the neuron, and they allow for the conduction of certain types of charged particles into the cell, all right? Pretty straightforward stuff. If it's a positive particle, the cell is going to become more positively charged. If it's a negative particle, it'll be more negatively charged. Very straightforward stuff, right? But you have to know that because what we're going to be talking about, what these guys did, is basically discover that there are certain types of these proteins or channels that are receptors for specific information. So that's really kind of the crux of this talk. Now, most of you guys have been told that you have 5 senses. How many here have been told you have 5 senses? Look at all these misguided, misled people. I can't believe you've been buying this since kindergarten. That's remarkable, remarkable. Okay, well, the point here is that you have more than that, okay? The sense of balance is a good one that we usually leave out. It's very important because we're fighting gravity all the time. And to know where we are relative to gravity, we've got to have a way to tell that. And that's your vestibular senses here, which is a mechanical sense. You also have a sense that was hard for your kindergarten teacher to spell. It's called proprioception, all right? That's a tough one, all right? That's your body sense or body awareness sense or muscle sense. That's a tough one. Very related to the vestibular senses because you always have to know where your arms and legs are. You know, if you forget, we don't ever forget, because that sense is always on, all right? So that's kind of interesting. All right, now the goal here is to basically convert certain types of energies that are out there in the world into a common form of energy that our silly brains can understand. And that type of energy is neuroelectric energy. So it's taking all of these reality-based energies and turning them into something that is created by our mind, all right, neuroelectric energy. So that's the goal in what we call sensory transduction. And the 2 guys that won the Nobel Prize here basically won it for talking about sensory transduction in one of the more mysterious areas of sensation and perception. That is your skin that you're living in, all right? This is your skin right here. This is like say about a square centimeter of skin. You can see that jam-packed in there. There are all kinds of these receptors. Lots and lots of receptors. Most of these receptors have to do with what you're traditionally thinking of as touch. And that's also known as hapsis, all right? Another kind is proprioception, which is your muscle sense or body awareness, which is something you probably hadn't thought of, but it's the general ongoing state of your muscles and feedback that we get from the joints and receptors around the tendons and muscles. Now, the kind that we usually don't think about with respect to touch are the ones that we're talking about today. And that's the free nerve endings. Free nerve endings. The free nerve endings. Free nerve endings give us information about pain and temperature. And there seems to be separate pathways for both hot and cold. So this in and of itself has 3 perhaps distinct modalities within it, all right, which is pretty neat, all right? Now, all of these things have rather discrete pathways, but the problem is figuring out what one receptor does is maddening because you can't really know because they're right next to each other. You stick your electrode in there to record, you're affecting another one right next door to it. So it's really hard to know what the relative things that cause these receptors to fire on. It's a problem. So what we do is we're lazy. We go upstream to where the nerves are, and we record from the nerves, and then look at what type of stimuli are affecting them. And the nerve that we record from for hapsis and proprioception is the alpha-beta nerve, all right? That enters the spinal cord through this process that's known as the dorsal root ganglion into the spinal cord, and then it stays on the same side all the way up to the brain, where it crosses the other side to let us know what's going on with touch. The ones that we care about are your C fibers, your C fibers. The C fibers come from the free nerve endings, and they cross the cord immediately to the other side, which is a good thing. It's a great design feature because if you set your hand on a hot stove, by the time you say ouch, your hand is no longer on it because your spinal cord has reflexively taken care of that problem for you. It's a great wiring diagram and it helps save your skin, all right? Because that's the goal of pain, right? These are the pathways that convey that pain information up to the brain. And it's pretty important to have these free nerve endings because you have to really protect your skin. Now we're finally to the point, all right? It took a while to get there. This is all the preliminary stuff that we had to talk about. But now we're going to talk about the work that Dr. David Julius did at University of California, San Francisco. And what he did, he looked at some of the various compounds and the effect that they would have on our sensory processes. And the one that he chose first is interesting. He chose chili peppers, red hot chili peppers, all right? Because they had a hot taste. Wait a minute, hot taste, taste and hot? That's weird. That's two different modalities. But he found that there was a certain type of receptor that became known as the TRPV1 receptor. The TRPV1 translates roughly to transient receptor potential, and this is the receptor that was identified as being affected by capsaicin, the compound in red hot chili peppers. So the neat thing about this is that not only did the chili pepper cause an effect on these fibers, so also did warming the skin. So if it went to 42 degrees Celsius, which translates to about 108 degrees Fahrenheit, all of a sudden this cell would start firing. It's a warning sign that the skin is getting too hot. Because, you know, if you get to about 118 degrees, that's where you get a first degree burn. So this is kind of like, hey, you're getting warm, you gotta get away. So these two things were combined, and this became the receptor for heat. He also did some work on another type of compound, which is mint. Cool mint. Let's have a mint julep, right? They're cool, it's cooling. What did he find? The same kind of thing. This type of protein, this type of receptor, the TRPM8, responded to mint and cooling of the skin. So he found two different receptors, all right, which is pretty neat. And I'm out of time, but I just want to kind of summarize by saying that these studies of Julius and Petapoupian did the same kind of stuff, all right? Same kind of thing. Found a different kind of receptor that responded to pressure, something known as a piezo receptor. And the piezo receptor is pretty important as well. So what we found here is that Julius and Petapoupian helped allow us to understand how heat and cold and toxins might be useful in solving some issues like chronic pain and other sort of genetic deficiencies that some people have. And that's all I have. That's kind of a rough, I guess it was longer than I thought.
Everyone. I'm Simon Lewis. I'm a professor of English at the College of Charleston. When this panel was first floated before the 2021 prizes were awarded, I suggested that we might actually have a hard time finding somebody able to talk about the winner, because the Nobel Committee has had a penchant for picking pretty obscure writers, at least writers who are often very obscure in the Anglophone, the English-speaking world. And then, hey, presto, out of left field, they pick an author whom I've not only written about, but somebody I've actually met and corresponded with, and whose work I really admire. All the same, Abdul Razak Gurnah is not exactly a household name, and so he's very much in the Nobel Committee's tradition of picking somebody a little bit obscure. He's an author of The Immigrant Experience, and he himself is not easily attached any longer to either his native country. He was born in Zanzibar off the east coast of Tanzania, nor to his country of residence, which is the United Kingdom. He is marginal, or marginalized perhaps. But that's, I think, why he is worthy of the Nobel's recognition, because what he has done in his novels is he has been able to chronicle the kind of marginal or marginalized experience of an extremely large margin. That is, the millions of displaced people in the world and the precarious limbo in which the undocumented or the insufficiently documented have to live. So when the prize was announced, news reports of Goerne first described him in national terms as Tanzanian, or even in continental terms as African, even though he'd lived in the United Kingdom since the mid-1960s. Within a few days of the announcement, the reports got a little bit more nuanced, and they picked up on the Nobel Committee's statement that Goerne was a novelist of migrancy and the refugee experience. Even so, news reports still tend to refer to him, even now, as a Tanzanian, even though he was scarcely known in that country before winning the prize, and he is in fact a UK citizen, longtime member of the English department at the University of Kent in Canterbury. You can't get very much more English than Canterbury. It's the centre of the Canterbury Tales, Geoffrey Chaucer, all of that sort of thing. So the phenomenon of insisting on a national identity, Tanzanian, or a continental identity, African, or a racial identity, black, when describing Goerne is kind of ironic, because that his novels have actually consistently unpicked such misleadingly incomplete identities. In addition, one of the reasons for his relative obscurity was that he didn't have an easy national affiliation. His identity does not fit national, continental, or racial categories. He was born in 1948, as you can see on the slide, on the island of Zanzibar, just off the east coast of Tanzania, just south of the equator. At that time, 1948, the island was ruled by the Sultan of Oman from the Arabian Peninsula, but it was under the control of the British. Thus, although Goerne is close in age to the anti-colonial first generation of African writers, that's people like Chinua Achebe, Wole Soyinka, Ngugi wa Thiong'o, who were all born in the 1930s, from 1930 to 1938, into colonial Africa, although he's that same generation, more or less, he doesn't actually fit a simplistic model of the empire writing back, anti-colonial writing. In fact, as an Arab-descended Zanzibari, he could in fact be placed in the category of one-time racial oppressor of other Africans. So sure enough, when the more unequivocally African revolutionaries overthrew the Sultanate of Oman in 1964 and took control of Zanzibar, when Goerne was a teenager, Goerne and his family were in deadly peril. Arab-descended Zanzibaris lost their lives, they had their homes confiscated, their wealth appropriated, and so on. Goerne has not actually made the revolution central in any of his novels, although it appears in a number of them. But many of them reflect his own departure for England in his late teens to get away from the revolution and that kind of atmosphere. And he was essentially in flight from a new nation to which he did not belong. His first novel, Memory of Departure, which you can see listed as being published in 1987, was a case in point. In fact, I would say that Memory of Departure, with the stress on the word departure, the title of that first novel, is a consistent theme throughout Goerne's writing. Previously, there's been another writer who is generally taken as being post-colonial, comes from a small island. He is not actually an indigenous native of that. I'm talking about V.S. Naipaul, who is from Trinidad, but of Indian parentage. And V.S. Naipaul has become very much an assimilated, or did become very much an assimilated Englishman, very much an English gentleman. One of his semi-autobiographical novels is known as The Enigma of Arrival. And I think it's very interesting to compare Goerne, who's driven by this memory of departure, with Naipaul, who's really fixated on this idea of the enigma of arrival, the idea of becoming British. But there's no satisfactory arrival, enigmatic or otherwise, for Goerne's characters in England. All of his characters, even the British-born Dottie, one of his early novels, are consistently confronted by assumptions about Africanness and racial otherness in the United Kingdom that constantly impede their ability to feel much more than a tolerable alienness. And that's a term that Gerner has used about his own experience in England. He says he's never really felt at home in England, he's only felt this tolerable alienness. Now, he's also a literary scholar, as you can see from this slide, as well as a novelist. So it's not surprising to find lots of literary allusions and comments on the role of language in the books. Generally to point out how canonical English literature and the English language itself has played a role in creating the sense of unbelonging that black immigrants in the United Kingdom experience. The character Latif, who's one of the narrators of the novel By the Sea, who says at one point he's been basically verbally assaulted by a very uptight English gent wearing a bowler hat and a suit, who's hissed at him near a subway entrance, says, "You grinning blackamoor." And Gerner, or Latif, writes about this. He says, "This is the house I live in, a language which barks and scorns at me behind every third corner." Now, if you're looking for a text to start with, if you want to actually read any of his work, I would recommend this one. This is the 1994 Booker Prize nominated Paradise. It's a novel, essentially a coming-of-age story, whose main character, Yusuf, who is very similar to the biblical character of Joseph. He's actually obviously a Quranic character, Yusuf, because it's the same person. Yusuf is a young Swahili boy on the mainland of Tanzania who's sold into a form of slavery by his father to pay off a debt to a wealthy Arab trader. The action all happens between about 1908 and 1914 as the Germans are taking control of Tanganyika, as that area was known at the beginning of the 20th century. And as that whole region of East Africa is about to implode with the outbreak of World War I. You guys probably think World War I's happening on the Western Front and trenches and the rest of it, but actually it lasted all 4 of those years beyond November the 11th, in fact, because they hadn't got the message that they should stop fighting. But the Brits had Kenya and the Germans had Tanganyika, and this novel is set just before that all bursts out. Anyway, as you can tell, even from this description that I've given of this novel, it's a historical novel, it's not a contemporary novel, but it bears all of the hallmarks of Gerner's fiction. You've got highly complex questions of ethnic, national, and racial identity. You've got issues of migrancy versus rootedness. You have questions of Europe's overarching power, not only to drive historical events, but also to write distorted, highly partial accounts of that history, accounts that then continue to exercise their own lasting and frequently damaging power over subsequent generations. So that's why you want it. Thank you.
Thank you very much. My name is Max Kovalov. I'm an instructor in International Studies program, and I study democracy, democratic erosion, democratic quality. I study why some countries become democratic, why some democracies collapse. And so for me, talking about the Nobel Peace Prize for 2021, when 2 journalists were awarded the Nobel Peace Prize for their work on freedom of the press, and this is how the Nobel Committee described this award. It's particularly relevant and particularly valuable. The Nobel Peace Prize, the committee says that the Nobel Peace Prize shall be awarded to the person who in the preceding year shall have done the most or the work or the best work for fraternity between nations, for the abolition or reduction of standing armies, and for the holding and promotion of peace congresses. The 2021 Peace Award was awarded jointly to these 2 journalists, Maria Ressa from the Philippines and Dmitry Muratov from Russia. And the way how the committee described their effort is for their efforts to safeguard freedom of expression, which is a precondition for democracy and lasting peace. This is not the first time that democracy was referenced in the Nobel Peace Prize, but this is the second time only in the history of Nobel Peace Prizes when the prize was awarded to a journalist or to two journalists. So the first time a journalist received the Nobel Peace Prize was 1935, and that was Karl von Ossietzky, who was awarded Nobel Peace Prize. He could not travel to receive the prize because he was imprisoned in a concentration camp in Germany. The 2021 award highlights the role of independent media and journalism as pillars of democracy. And with this award, the Nobel Committee highlighted signals that free media, independent journalism, and democracy are in danger. They're not just developing as, it's not just business as usual. And when we think about democracy, the first things that come to our head is elections. If there is an election, if there are elections, there is democracy. But democracy is more than just elections. And elections are necessary, but not a sufficient condition for democracy, as many students of democratization have been arguing for many years. And there are other important functions that democracy that countries have to have to pass the threshold of to be called democracy. And those are freedoms: freedom of expression, freedom of association, freedom to the ability to protest against your government, and access to independent media. Independent media that is not controlled by the government, by the state. Just to give you an overview of broader context about the media in the world, the freedom of the press in the world, what's happening in the world. Non-governmental organizations such as Freedom House have been documenting over the last decade that the freedom of the press has deteriorated significantly over the last decade. So, and the different NGOs have been measuring democracy and freedom. They really have a grim outlook on democracy and freedom of the press. And this map shows that the darker colors, you see that those are countries that where press is not free. The lighter colors, those are countries where press is free. You see that there are more countries in the world where press is not free, where journalists do not enjoy freedom to speak out and then to report. And other organizations, the Reporters Without Borders, estimate that 73% of the countries, in 73% of the countries, journalism is blocked, either partially or fully. So journalism and free press and free expression has been kind of on the ropes over the last decade. And it's not just the countries that are run by authoritarian leaders. It's also countries, European countries, that have been there have been attacks against journalism and journalists in European countries. The governments around the world are particularly concerned about freedom of the internet, and so they pour resources to trying to establish control over the internet. And so the Freedom House also reports that for the 11th straight year, in the year 2021, experienced a decline of freedom of the internet. So 11th straight year in a row. So what these two slides show us that freedom of the press is down. Freedom of the press is not largely free around the world, and so the internet is not free. What's happening in Russia and the Philippines? Russia has ranked 150th in the media freedom. The Philippines ranked 136. And it's not just about harassing journalists, it's also about killing journalists. Journalists that are attacked around the world. Since 1992, so the last 30 years, more than 1,400 journalists have been killed around the world. 88 journalists were killed in the Philippines and 58 journalists killed in Russia. Russia has been steadily putting pressure on independent journalism since 2011. Journalists who were covering prominent stories, the arrest of opposition leader Alexei Navalny, his arrest, his poisoning, his trial, they are targeted themselves. And so Russia also has been legally prosecuting people who are journalists by different journalists and bloggers. Journalists are branded as foreign agents, and so the fifth column. In the Philippines, the biggest broadcaster has been off the air for the last year or so, and this was done for the first time since 1972. Under the current president, Rodrigo Duterte, 19 journalists have been killed. Many journalists are imprisoned. So journalists are prosecuted, targeted, imprisoned, and so harassed in different ways. So this is the kind of context that under which this decision for the Nobel Peace Prize was made. The Nobel Peace Prize was one of the recipients, Maria Ressa. Apologies for writing or for the not capitalizing her last name. She is from the Philippines, and she founded this new online news site, The Rappler, in 2002. Her work has been exposing the government's war on drugs. In 2016, Rodrigo Duterte, when he came to power, he won presidency, he declared the war on drugs. And so that war on drugs included extrajudicial killing, mob violence, and violence by vigilantes. And since 2016, over 12,000 people, Filipino citizens, ordinary citizens, were killed in this extrajudicial violence. And journalists who are reporting on these crimes are also targeted by the Duterte government. And so Maria Ressa was one of those who was a critic of Duterte, who's been reporting on these incidents of extrajudicial killings. In her dedication, she criticized the network of disinformation that journalists have to operate on and have to fight against. She was concerned about the lies against journalists, lies against the minority groups, LGBT groups, women, and so the second point that she was concerned about, that was social media and Facebook. And she was concerned that social media are spreading lies because they're just treating it as another data point. Lies are easier to be picked up, they spread faster than facts, and so essentially she is accusing social media, and the biggest platform, of being the biggest threat to independent media and democracy. On the Russian side, the winner of the Nobel Peace Prize was Dmitry Muratov, the editor-in-chief of the newspaper Novaya Gazeta. And he has founded the Novaya Gazeta in 1993. Mikhail Gorbachev, the winner of the 1990 Nobel Peace Prize, actually donated part of his prize, and then he to buy equipment, computers, and to pay for his salary. So he founded this newspaper, and then today this newspaper is one of very few remaining independent sources of media in Russia. And what the reporters have been doing over the years, they have been exposing corruption, they have been exposing abuses of power, they have been reporting from Chechnya. And you see that there is this chart here. I pulled Google Trends from Google just to show how, what kind of things people are, when people are searching Novaya Gazeta, the name of the publication of the newspaper, this is what Google Trends show. And there are a couple of peaks here, and these peaks are killed journalists. In 2006, Anna Politkovskaya, who was the journalist for Novaya Gazeta, was assassinated. She was reporting on Chechnya. This was the day later that year when her first murders were identified in this case. And in 2009, another independent journalist that was working with the Novaya Gazeta was assassinated, Natalia Estemirova. Natalia Estemirova was a human rights activist and a board member of the human rights organization Memorial, the organization that was shut down late last year by the government. And in his reception speech, Dmitry Muratov said that I want journalists to die old, and this kind of briefly captures the essence of this award and his concern and what the kind of conditions the journalists are operating under today. This is my final slide. The reception, domestic reception of these awards. Vladimir Putin congratulated Dmitry Muratov. He said, first of all, I would like to congratulate you with the awarding of Nobel Peace Prize. And then Muratov said that he's going to donate most of the money to charitable causes. and putting added, you said about the hospice, I would give you an award for doing such noble work if it's true. So there is a caveat, but he is willing to, but at least he recognized their work. Duterte did not congratulate Maria Ressa. His spokesperson said that yes, it is a victory for Filipina, and we are all happy for that. That actually, the victory is the indication that freedom of the press is live and good and well in the Philippines. And he also made a caveat that Maria Ressa has to report for all of those cases that she's prosecuted in the courts. There are legal cases that are pending against her. So don't forget about those. Duterte called Rappler, the publication, as a fake news website a couple of years ago. It's interesting that the Nobel Peace Prize is awarded or was initiated by Alfred Nobel, a Swedish producer of military weapons. And perhaps this was one of the ways to compensate for his way to compensate for developing destructive forces. Thank you.
Good afternoon. Let me talk about the Nobel Prize in Economic Sciences, which was awarded to David Card, Joshua Ingres, and Ibbins. Unlike my predecessor, I don't have any slides. This will be an oral presentation. But so, beginning in the early 1980s, there was a credibility revolution in empirical economics, specifically around the application of better research designs. And this is the reason these three economists were awarded the Nobel Prize. Like David Card wrote a famous paper about studying minimum wage laws in Pennsylvania, and you can't go through grad school without reading that paper about the research design. So prominent research designs that have come out of this credibility revolution are what are called instrumental variable methods, regression discontinuity designs, and then what's called difference in differences policy analysis. Now, the DID, or the difference in differences strategy in particular, is especially popular, and up to, some studies have estimated up to 1/4 of all studies in the top economics journal, which is the American Economic Review, apply the difference in differences in design. And just to give you a preview of the way I think about the DID design is, why is it so popular? So once a policy shock hits, so you can think the minimum wage laws has changed, we have no alternative state of the world. So how do we know what happened to the world had the policy shock not been implemented? And that's what this design does. And the easiest way, the simplest example to think about is a twin study. So Senator Mark Kelly from Arizona is an astronaut, and he has a twin. And so we want to study the impact of space travel, if you will, on an individual's health. So what do? We need a twin. We need an astronaut who has a twin, and hence we can send Senator Kelly into space. And then we have the perfect, what would happen if we didn't send him into space with his twin, then we can then compare the two and see what happens. Other recent advancements in statistical techniques, such as synthetic controls and matching estimators, have also allowed us to improve research designs, which has allowed economists to build even stronger identification strategies than we were able to beforehand. And so building behind all of this, the improved research designs has allowed us to better understand causal relationships in economic research, instead of just identifying correlations in the data, which is kind of what was happening before the credibility revolution occurred.
Well, I want to take an opportunity to open up to any questions that anyone may have for any of our panelists about any of the prizes they have presented.
First, I'd like to remember the name of Dr. Robert Bernstadt, a Charlestonian who won the Nobel Prize. I had the honor of knowing him and through his family, but I also had an auto wreck with him. He was going to golf, and we had a meeting that way. But anyway, my question is, in these widely divergent fields in which these awards were awarded, is there an implication perhaps for notions such as the uniformity of nature or the immutability of certain laws, whether they be in physics, chemistry, and presumably less hard theories in such fields as economics and psychology? What do all of these portend for some sort of continuity among the disciplines rather than current large discontinuity?
I'll get started. When it comes to these physics related awards, the part of the reason that the Nobel Committee did complex systems was because of the idea that the same type of analysis you would use to find pattern recognition within natural systems that have seemingly random behavior, the idea is that the same sort of analysis can be applied to social systems and other sort of phenomena. And so an example of this would be the following. In a natural complex system, one of the things that we are concerned about is that even if something appears to be strictly random, what we observe is that there are some states of atmospheric systems or other complex systems in which they get stuck in a particular suboptimal pattern in which basically nothing can happen, nothing can kind of force it out. And so that was part of the research of Giorgio Parisi, is examining how a complex system can get stuck in a particular state and cannot kind of escape it. So the idea was that was used to describe some features of kind of standard human behavior. So he gave the following example, and it's an example that appears in different sort of situations. Let's suppose you're at a party and you have multiple people in the room, and you kind of have the social dynamic where I want to talk to that person wants to talk to that person, but he doesn't want to talk to any of the three. And so the question is, if you just kind of allow natural processes to work in a room, will I get to talk to someone I want to talk to, or will I get forced to talk to someone I don't want to talk to, say him? And the idea would be that there are actual social implications of that idea, that you can actually have a random distribution of conversations, in a sense, in which you get stuck in a state where you can't escape. In a party scenario, that will be as if you're in a party where every person you talk to you despise for some reason, and you can't really escape. It just kind of keeps going around. The analogy was that's something kind of what happens in a climate system, that you can get stuck in a atmospheric state based upon external forcing, where the entire global system can't really push itself out of it, and you kind of get subsumed in there. So the point is, much of what the complex system idea is meant to do in the physical sciences, the idea was to see, does that sort of stuff apply to social sciences and things outside of it? So basically what we're discovering, broadly speaking, is that there are strong analogies between how natural physical systems operate and what we typically think of naturally organic social systems in operation. So that's one way in which some things are converging. The complexity of human behavior and natural behavior seem to have an analogous mapping to one another. That's my answer. Anyone else?
I can. So one of the problems with economics, I mean, social science research in general, is the non-random selection of the treatment. And so what Card and the other economists have done is they've really shown that our natural experiments, where the researchers themselves aren't in charge of who receives the treatment, and those natural experiments that arise from policy changes, they are going to better resemble controlled or laboratory experiments. So it really helps take care of our selection bias problem without studying human beings. So it would better match kind of like a natural science world that has more random elements to it.
you're asking sort of what are the underlying principles that sort of tie all of the awards together, not necessarily the awardees, but the idea of the awards. I think you probably are looking at something which is essentially a sort of a steady outgrowth from the humanism of the sort of 16th century, the birth of European universities and the liberal arts, through the Age of Enlightenment, and then through the 19th century when you get this whole sort of positivist attitude which actually derives, which creates a whole lot of new sciences, including social sciences, sociology, and all of that sort of stuff. Statistics actually kind of gets born in the 19th century as a discipline and so on. And I think what the prizes mean is that this is kind of the apogee of a kind of teleological understanding of humankind, right? That we are actually getting better. In the 19th century, you have people like John Stuart Mill actually talking about the perfectibility of humankind. And even somebody like Marx actually has this kind of positivist idea that actually you can have stages, and eventually things are going to get better and better and better until the state can wither away, that kind of thing, right? So I think really having the awards just says, okay, there are all of these branches of human understanding, but people are getting better and better and better, and we need to encourage people to get better and better and better by awarding those who are doing the best. So I think that's essentially the underlying principle behind the awards as a group. They were founded in 1904, something like that.
I also have a comment. So, but first of all, I appreciate you pointed my direction when you said Marx. And second, what unites, I think, all the words and what kind of sets apart the Nobel Peace Prize award is that these all awards, all of the awards aside from the Nobel Peace Prize, they're given for something that has already been done, that has already been achieved. Sometimes these achievements happened 30 years ago, 20 years ago. No, the Nobel Peace Prize are often given to candidates or to people, politicians, organizations for the work that it's just ephemeral, but it's not there. It's a hope that an individual or the organization will continue doing the good work and continue promoting ideas of peace or ideas that this individual is engaged in, so that there would be some kind of contribution to peace. And that's why there is a lot of controversial nominations and awards in the Nobel Peace Prize. When people are shrugging, why is this individual received the Nobel Peace Prize? And then several years later, there are also a lot of backlash against individuals who received the Nobel Peace Prize. And a couple of examples from the past, the Prime Minister of Ethiopia who received the Nobel Peace Prize in 2019, is now prosecuted, or he's not prosecuted, but he's accused of sponsoring a military effort in the Tigray region in northern Ethiopia. Aung San Suu Kyi, the now imprisoned leader of Myanmar, won the Nobel Peace Prize just before she turned on the Rohingya refugees who were fleeing from Myanmar. So there's a lot of controversy, in other words, in the Nobel Peace Prize. I don't know if there are similar types of controversies that exist in other prizes.
So it's in the chemical sciences. It's interesting because there's a heart of it. At the heart of it, oftentimes, is what is chemistry. And this is what we all think about, right? When we think about chemistry, we think about molecules and bonds. And in that same token, the Nobel Prize in chemistry often hits a rather kind of seemingly disparate field. But there is, where 1 year you can have someone get a Nobel Prize for the development of green fluorescent protein, and where throughout molecular biology and human physiology, the ability to light up portions of cells and see them has been remarkable. Or the same way you can find a molecular biologist winning awards in physiology and medicine, we have molecular biologists winning Nobel Prizes in chemistry. But one of the things that I think in the sciences that sets it interestingly is that when you're doing research, you really can't know at the beginning what it's going to mean. Right? The ability to make a single bond in 3 dimensions and control it. We knew why it was important, but the ability to get it to work, it's very hard to know what that's going to mean. That's why I included that slide where we saw that near exponential growth and just how fast that the ability to do that took off. Because if we rewind 100 years, the chemist Bredig showed that you could use organic molecules as catalysts to make bonds in 3 dimensions, and you could do it successfully. That sat for 100 years. It sat for 100 years in the scientific literature, first uncovered in 1912. And there have been a couple really interesting examples throughout history. But if you want to think about sort of kind of translational impact when you think about something like a small chemical bond, oftentimes the debate that comes around chemistry is it all chemistry? Why is a molecular biologist getting a chemistry award? Like, well, what's a protein? It's made of carbon and hydrogen, nitrogen, and oxygen. It has a 3-dimensional shape. And so what I try to tell my students is that there's this amazing continuum where you can go from subatomic particle physics up to a population of living organisms. And oftentimes in the sciences, when there's a Nobel Prize awarded, someone took their little piece and niche along that continuum. And by fundamentally doing good science and exploring to the full potential of that result, it effectively leaves ripples to either end of wherever they were, both at a smaller scale and at larger macro scales. So the design of new catalysts that can make bonds, the catalysts we use now that I myself used as a student, were very different than the ones that the Nobel Prize winners this year won. The medicines that we make now are far more sophisticated than the molecules they were initially able to make with these synthetic methods. And all the way up through appreciating the new and improved ability to generate molecular complexity has rethought a lot about how we think about new medicines and new therapies and new regimens, especially when it comes to things like neuroscience. Right? And so, where does that all come from? And some scientists somewhere thought, I want to make this bond, and I want to make it only this way. And the impact, again, on that continuum rippled outward, both smaller and bigger in a way. So and they seem disparate, but they are, especially in the sciences, they're massively linked. And what are the societal impacts? In terms of new bond-forming reactions developed in the last 20 to 30 years, there isn't a person in this room who has not taken a medicine made with some catalytic method. Right? There's not a human being on this college campus who has not taken a medicine made with a catalytic method. Not necessarily organic catalytic, but it's a massive field of chemistry. Right? And so what are the societal and social impacts of that? Right? When we think about the impact that being able to target a neurological receptor has on social mental health. Right? And so it's hard to say, okay, the scientist who thinks about one bond, is that really a disparate field, say, from the neuroscientist or a population psychologist? But they're inexorably linked on a massive continuum.
We have time for maybe one more question.
Yeah, I've got something to add to this too. I think if you really look at science, science is a great thing. Sometimes you could have a goal of curing something. Sometimes you could have an idea of just finding something out. And I think what's wonderful about the Nobel Academy and the way that they do things is that it really focuses on the humanity of the questions that are being asked. And it allows us as scientists to strive for something better, to make sure that we're going to be careful in what we do and give the right results and make sure that, we're disseminating them to the people that need to read them. I think it's an important thing to share, and I think it's an important thing to recognize. And I think that's what the Nobel Prize is doing. I don't think Nobel himself had any idea about the impact of what he's doing here. But it's going on. And I think it is advancing humanity. And I think it is advancing our desire to be better. And I think I'm an optimist. And I like to believe that going forward, we're going to have that. And I think science is at the front. And I think that asking questions and appreciating things is also important. And I think that courage is the most important thing. And I think Nobel recognizes that.
I'll wrap up and add just one thing here, and that is, why did I want to do this? And sort of thinking about this is that it is this idea of bringing the liberal arts and sciences together, which is I think what Garrett's talking about. I think that's really great for me, right? The idea that economic systems, which I think to Gabriel are complex, and that we need to have better ways to think about these complexities, right? That these systems aren't as simple as we think, and we have to be really thoughtful then about not only in the physical world, but in the social sciences, right? How are we dealing with complex systems? And realizing and recognizing that we're dealing with human beings, right? That have very different preferences, different sets of things, right? But how do we allow them to flourish? How do we allow them to grow, and how do we allow for them to be able to make better decisions, right? And to be able to then experience the better things, right, that societies can give us, the better medicines, right? The better knowledge, the better understanding of how these things work, right? Whether it's the development of models and sort of looking at now, in the case of econ, right, of now being able to do things that aren't just simulations, if you will, right, but actually looking at natural experiments that can actually tell us, is this policy going to succeed or not, right? The counterfactual is really hard, and now we're finding ways to start to talk about the counterfactuals and to talk about complex systems, right? When we have economic systems and social systems that let us do that, right, society, I think, as a whole grows and becomes better. So, and that happens across all these areas, right? Because these things then become commercialized, and they become ways that become medicines, they become things that help us to live better lives. Whether it's the institutions, right, in the form of democracy, or right, it's the actual physical medicines and things like that, or the atmosphere around us. So, if there are any other questions, I just want to take the moment, right, to thank our panelists. This is something that I'll just say that I hope this is the first of an annual tradition. And I look forward to the opportunity to be able to do this next year. So, I'm going to thank our panelists.